So we go with the chapter 1, an overview of computer and programming. You will learn about the computer system, a simple programming logic, the step involved in the programming development cycle, pseudocode, flowchart, sentinel value, programming and user environment, and the evolution of programming model. So the first thing you have to understand what is computer system. The computer system, it is a combination of all of the components required to process and store data using the computer. So basically they break it down into the hardware and the software. Right? So we see everything is the hardware, very easy to see, monitor, a keyboard, mouse, and system unit, something like that. And software is everything that it's instruction. It tells you how to do and it processes it here. And in the breakdown, we have the program. Program is a instruction written by the programmer, and programming it is a process of writing software instruction. So they are not the same. Program it is a combination of the instruction to tell how computer works, right? And in order to working with instruction here, you have to write something onto that. You that convert it to the software instruction here. Okay, computer hardware and software. You have the 3 major operations. It is input, processing, and output. So its own way. The computer basically, if you don't tell it what to do, you have nothing to do with that. It have nothing to do with that, right? So if you turn it on, it stays there. If you need something, you have to tell them what to do. You have to tell computer, or you have to give the input here, right? You have to give the input. So basically, for the computer, you have the 3 major operations here. It is input, it is processing, and it is output here. Right? So in order to tell computer to do that, you have to give some input to do that. So input here, you can get the input into the computer by the keyboard, by the mouse, or by the voice control, or something like that. Right? And processing is something you have a lot of instruction on that one. You have a lot of processing. So based on the input, you can do a lot of processing time, and after that, it's send out the output. Is what you expected here. I think the output here can be the monitor screen here, can be the printer, can be the speaker, something like that. Okay, so you have the input, it's a data item such as text, number, image, and the sound. Processing, everything about calculation. So we think about if you want to print out the sum of the 2 numbers. The thing is, if you want to print out the sum of 2 numbers, you need to hit input. It is 2 numbers, X and Y. That is input. Now, if you want to do the sum, you have to do calculation here. You have X plus Y. You have X plus Y. It's a calculation. And the last thing, you need to print it out, or you need to show it up on the monitor. It is output. So remember, for computer, you have the 3 major operations only: input, processing, and the output here. Okay, so information is sent. It can be sent to the printer, monitor, or the hard disk driver. You want to set it into the computer disk here, right? And nowadays, you heard a lot about you hear a lot about the cloud, right? The Google Drive, something like that. Okay, so you go with the component of the computer. You have the central processing unit. That is, if you look on this one, this is central processing. So in the central processing unit, you have a lot of components on that. You can have the internal memory. It is RAM. You can have a ROM, and you can have the mass storage device. So the RAM. I'm talking about a little bit about what is RAM or the ROM here, but remember that if you're working about the if you're working about system unit, sorry, you have this one is system unit. System unit. This one is system unit. You have the CPU, you have internal memory, you have mass storage device. It can be the HDD here, HDD or SSD, and nowadays you can save into the cloud and so. You can save it to the cloud. And so for the input device, you can have the keyboard and mouse output. You can have the monitor operator. Okay, now remember you have the system unit. You have CPU, you have ROM, you have RAM, you have motherboard, something like that. Right? And in the system unit, the CPU here, it is the brain of the computer. Because it do everything in calculation, processing. Right? It's a CPU. It is the brain of the computer. It receives the program instruction. It performs arithmetic and logical operation and control other computer components. It controls everything. So it's controlled by the keyboard, the mouse, everything. Right? And in the CPU, it consists of millions of transistors on a single microchip that plug into the motherboard. Right? And the speed of the CPU is measured in the gigahertz. So if you have the high gigahertz, that means you have a powerful processing here. Right? And you can think about gigahertz is a 1 fluctuation here. That is 1 hertz. Right? So gigahertz, that means you have 10 raised to power of 9 hertz. That means 1 second it can do about what is it? Billion of processing. Right? A billion of calculation here, operation here. Okay, now we move to the RAM and ROM. The ROM is a read-only memory. The read-only memory, that means you only able to write onto that, but you are not able to. Sorry, it's a read-only that you only able to read it for that. You have no way to write onto that. And the ROM is a content instruction used by the computer during startup. The ROM is everything about interface with the hardware. Right? So when you power on the computer, actually when you power on the computer, you always have the process of POST here. Power on cell state. So when you power on, the ROM interface with the hardware, you have to check everything to make sure the hardware working smoothly or not. Right? So you have interface with the keyboard, you have interface with the mouse to make sure everything working well or not. Right? That is the ROM. You cannot change it by the computer either. You cannot change it. That is ROM. Remember, the ROM is the instruction to control the hardware during startup. And the second one is the RAM. The RAM is a random access memory. You can take this a scratch pad here for the user. Remember this one for the user. You can write on that, you can read on that, but this is a temporary only. So when you reload the computer, if you don't save it, everything gone. Everything gone. And the RAM is measured in the megabyte or gigabyte here. Okay, so now we go to the basic units of memory. Every computer, underlie of every computer, is working in binary. It's working in binary. Working the binary system. Binary system for units of binary is a bit here. The bit. So you have 1 bit. You have 2 values for 1 bit. It can be 0 or it can be 1 here. All right. The thing is only working with 0 and 1 because you can think about electricity here. You have a switch, right? So when the switch on, the light on. When the switch off, the light on. And the CPU, you have million of the switches in the CPU. That's why underlie of every processing computer is working with 0 and 1. You have many million of circuits on that. You have million of switches on that. So switch on is 1, switch off is 0. Right? So that is a bit. You have another thing is a byte. 1 byte is a consist of 8 bits. 1 byte is 8 bits here. Right? And on that you have the kilobyte, you have megabyte, you have gigabyte and so on. But remember one thing. 1 kilobyte it actually is not 1,000 bytes. It's not 1,000 bytes. 1 kilobyte it is a 2 raised to power of 10 here. So when you have 2 raised to power of 10, actually you have 1,024 bytes, not 1,000 bytes. And the same, 1 megabyte it is a 2 raised to power kilobyte. So that's why you have 1024 kilobyte here, and the same is going to be here. Okay. Anyway, somehow it is close to the 1000. That's why it's not a big deal here. All right. Okay, so now you're talking about system unit. In system unit, you have CPU is the brain. It's the brain of computer. It handle everything about processing, calculation. The second one, you have memory. In memory, you have ROM, you have RAM, and you have the mass storage device also. As a mass storage device, you can save something into the hard disk drive here, SDD here, or can save it to SD nowadays. It's way faster here. And you're also able to save it into the optical storage. It can be the CD or DVD. You can save it in the SSD nowadays. It's flash drive plugged into the SSD port, or nowadays you a lot with the cloud computing. So the benefit of cloud computing is that you're able to access it anywhere, providing that you have internet access. So you don't have to worry about how the data loss here. It's a lot of things with the backup. All right. Okay. Okay, so now you only have the three major operations: input, processing, output. Right? And for the input, you can have the keyboard, you can have mouse, you have digital pen, modem or wireless modem, you have internet connection, touch screen, joystick, voice command, and more. For the output, you can have a monitor, printer, speaker, anything. It brings the output here. Okay, so remember, computer, you have two components, software and hardware. Hardware, everything easy to see here. And the software, break it down into two types of software. You have the application software, and you have the system software here. So application software is you have some function with the application software. The first one is enhance productivity. The second one is solve problem, supplies information, provide entertainment. An example of the application software, it is a word processor here, Microsoft Word, Microsoft Excel, Lightroom, or what else? You have a lot of application here, right? What is something? Photoshop. Sorry, I want Photoshop because I love working with the photography. Okay, that is everything about the application software. The second one is system software. System software is everything about how to control the hardware, right? And you have the operating system here. Operating system, it controls the hardware and also interface with the end user. You can think about the window here. Window actually is control everything about the hardware and also interface with the user here, right? So it control and maintain the hardware. It communicate with the user, and it manage and communicate with application. It can be the window, DOS, Linux, or Unix. Okay. Any question? Any question? Any comment? Please let me know if I go too fast. You just tell me I need to slow it down or something like that. Anything? Any question or any comment? Everything good so far? Okay. Okay, so now we go with the programming language. You have the software. Now we go with the programming language. That is the process how you write the programming, right? So basically, you have two types of programming. The first one is the low level. The first one is the low level. The second one is the high level. Okay, so in the low level, it can have the machine language or it can be assembly language. It's the low level. In the high level, you have a lot of language. It can be the Java, JavaScript, C++, C#, Python. You have a lot of the high level programming here. Okay, so I think it should be better if you watch a video. You will have the overview. What is low-level language and what is a high-level language?
A program is a set of instructions that tells a computer what to do in order to come up with a solution to a particular problem. Programs are written using a programming language. A programming language is a formal language designed to communicate instructions to a computer. There are two major types of programming languages: low-level languages and high-level languages. Low-level languages are referred to as low because they are very close to how different hardware elements of a computer actually communicate with each other. Low-level languages are machine-oriented and require extensive knowledge of computer hardware and its configuration. There are two categories of low-level languages: machine language and assembly language. Machine language, or machine code, is the only language that is directly understood by the computer, and it does not need to be translated. All instructions use binary notation and are written as a string of ones and zeros. A program instruction in machine language may look something like this. Technically speaking, this is the only language computer hardware understands. However, binary notation is very difficult for humans to understand. This is where assembly languages come in. An assembly language is the first step to improve programming structure and make machine language more readable by humans. An assembly language consists of a set of symbols and letters. A translator is required to translate the assembly language to machine language. This translator program is called the assembler. It can be called the second-generation language since it no longer uses ones and zeros to write instructions, but terms like move, add, sub, and end. Many of the earliest computer programs were written in assembly languages. Most programmers today don't use assembly languages very often, but they are still used for applications like operating systems of electronic devices and technical applications, which use very precise timing or optimization of computer resources. While easier than machine code, assembly languages are still pretty difficult to understand. This is why high-level languages have been developed. A high-level language is a programming language that uses English and mathematical symbols, like plus, minus, percent, and many others, in its instructions. When using the term programming languages, most people are actually referring to high-level languages. High-level languages are the languages most often used by programmers to write programs. Examples of high-level languages are C++, Fortran, Java, and Python. To get a flavor of what a high-level language actually looks like, consider an ATM machine where someone wants to make a withdrawal of $100. This amount needs to be compared to the account balance to make sure there are enough funds. The instruction in a high-level computer language would look something like this. X equals 100. If balance less than X, print insufficient balance, else, print please take your money. This is not exactly how real people communicate, but it is much easier to follow than a series of ones and zeros in binary code. There are a number of advantages to high-level languages. The first advantage is that high-level languages are much closer to the logic of a human language. A high-level language uses a set of rules that dictate how words and symbols can be put together to form a program. Learning a high-level language is not unlike learning another human language. You need to learn vocabulary and grammar so you can make sentences. To learn a programming language, you need to learn commands, syntax, and logic, which correspond closely to vocabulary and grammar. The second advantage is that the code of most high-level languages is portable, and the same code can run on different hardware. Both machine code and assembly languages are hardware-specific and not portable. This means that the machine code used to run a program on one specific computer needs to be modified to run on another computer. Portable code in a high-level language can run on multiple computer systems without modification. However, modifications to code in high-level languages may be necessary because of the operating system. For example, programs written for Windows typically don't run on a Mac. A high-level language cannot be understood directly by a computer, and it needs to be translated into machine code. There are two ways to do this, and they are related to how the program is executed. A high-level language can be compiled or interpreted. A compiler is a computer program that...
Okay, so I stop here. So let's review about that. Okay, so you have two types of programming language, right? You have the low level. You have low, and you have high here. And in the low, you have two categories. The first one is the machine language. Machine. sorry. This should be this one. The machine. And the second one, you have assembly here. So for machine language, it is everything working is 0 and 1. It working directly with the hardware here. And underlying every computer, you know that it's working only with 0 and 1. So when working with the machine language, you working with 0 and 1 here, you have benefits. You have a lot of benefit with that. It works very fast. You don't have to translate it to 0 and 1. You don't have to translate it. You don't have the thing. The first one is you don't have to translate it. That it works very fast here. It works very fast. That's the first benefit, right? The second one is that when you don't have to translate it, you optimize the resources. You don't need anything about the memory here, right? Basically, if you want to compile or if you want to translate it, you need a buffer. You need a buffer here. You store everything and you processing here. Right? That here directly working with the hardware, you don't need to translate it. That's why you can optimize about the resources of the hardware here. Right? That is the benefit. But what is the disadvantage here? What do you think? If you watch it in the video, what's the disadvantage? It's hard to understand. Right? You have to totally understand about 0 and 1, about the hardware. And the second one, it is hardware specific. Sorry, specific. It's a hardware specific. That means you have to totally understand what is hardware here. So think about this keyboard. It's a Dell keyboard. You have to work in 0 and 1 for Dell keyboard. But if other one is HP, you have to change the code here. Right? You have to change the code here because it is hardware specific. Right? So that means that if you write the coding in the one computer, you move to another one, you have to change the code. Otherwise, it's not work. It is specific. So you have benefit. You have some advantage here. It works very fast and it optimized for the process for the resources. But the second one, the disadvantage is very hard for you to understand. And it is hardware specific. So you have, if you move from one computer to another one, you have to modify it. Right? So to make it a little bit simple, with a machine here, they group some of the 0 and 1 together. It's a, you have group into the move or add something like that. It moves to the assembly here. So assembly a little bit easier for you to understand, but it's still hard for you to understand. And again, under live computer, everything is 0 and 1. So from assembly language, again, you have to translate it to 0 and 1 here, if you want to work it here. Okay, and again, this one also hardware specific. Now, for the high level language, it is easy to understand. You can think about it's the same with the normal language here. It's very easy for you to study, easy for you to understand it. That is the benefit of that. But of course, you have some disadvantage here. The first thing, you have to translate it to 0 and 1. Because the hardware, everything hardware working with 0 and 1 here. So when you translate it from the high level to the low level here, you translate it to 0 and 1. So when you translate it, it is slower. Of course, it takes time to processing. Okay, when you translate it, you need something with the memory here. You need the buffer to store the instruction here. That is a slower. You need something with memory, but of course you have advantage. It's easy to understand, easy to study here. And anything else? Okay, so right now is that remember you have two types of of the software. The high level you have two types of language. Low level language and high level language. And the low level language, you have two categories. You have machine language and you have assembly language. And in the high level, you have a lot of language. You can have a C++, C# or Java or Python, a lot of them. Okay, any question for this one? It clear or not? If anything is not clear, let me know. Okay. Now, again, programming language is used to write the computer instruction. That remember, program it's a set of instructions to tell computer what to do here, and it calls the program code, and writing instruction is called the coding the program. And some of the programming language, it can be Visual Basic, C#, C++, or Java. Now you have something you have to remember about the programming language. The first one is syntax. Syntax, you can think about the grammar. Yeah, syntax is a grammar. So syntax is rule. Syntax is a rule that governing the word usage and punctuation here. And in mistake in the language, use it as a syntax error. So syntax error, you can think about this one. If you need to write a program to calculate the area of the rectangle. So think about if you need to print out what is the area of rectangle here. And in order to print out the area of rectangle, what do you think? What do you need? You need the width and you need the length here, right? So this one is the length. And this one width here. So width and length, they are input. Width and length, so we can think about you have input here. Input, you have processing, and you have output here. So in order to print out the area of the rectangle, so we can think about area here. Area is output. It's what you expect to print out here, right? This area is the output. And if you think in order to print out the area, you need the length and you need the width here. So you have to ask the user, please enter the length and please enter the width here. So think about the X here is the length and Y it is the width here. Now the computer already got the input. Now it moves the processing. Processing here, you have to write the code. You have to tell what you have to do here, right? So we have to put it here, area. Area, basically you have length times Y times width here, right? So we have X times Y here. Right? And after that, you have area, it's a print out area here. But somehow, if you put the area, if you write the code here, area equal to X, but what is it? Let me see. You have put the sharp Y here. That is a syntax error because the computer doesn't understand what is the comment with this one. What is syntax of this one? So in that case, you have the syntax here. And whenever you have the syntax error, the program, when you run the program will be stopped. Program is stopped, and they tell you have the syntax error. So in that case, you have to go back to fix it. Right? So whenever you have syntax error, when you run the program, you have no way to run it smoothly. You got the notification, what is error here, and you have to go back to fix it. Okay, so now you have a process of compiler and the interpreter. So that review about the high-level language. You have a high level. Remember that in order to have program run on the computer, everything you have to convert it to 0 and 1. Every program you have to convert from the high level here. You have to convert it 0 and 1. It is machine language. And the process of convert everything from the high level to the machine language, it is a compiler or the interpreter here. So we see what is a compiler or what is the interpreter.
A high-level language can be compiled or interpreted. A compiler is a computer program that translates a program written in a high-level language to the machine language of a computer. The high-level program is referred to as the source code. A typical computer program processes some type of input data to produce output data. The compiler is used to translate source code into machine code or compiled code. This does not yet use any of the input data. When the compiled code is executed, referred to as running the program processes the input data to produce the desired output. When using a compiler, the entire source code needs to be compiled before the program can be executed. The resulting machine code is typically a compiled file, such as a file with an exe extension. Once you have a compiled file, you can run the program over and over again without having to compile it again. If you have multiple inputs that require processing, you run the compiled code as many times as needed. An interpreter is a computer program that simulates a computer that understands a high-level language. This means that the interpreter translates the source code line by line during execution. Consider again a computer program that processes some type of input data to produce output data. The interpreter executes the code line by line, which results in the desired output data. The only result is the output data. There is no compiled code. When using an interpreter, every time you want to run the program, you need to interpret the code again, line by line. There is no compiled code to use if you have multiple inputs that require processing. To understand the difference between compiling and interpreting, let's examine the equivalent in human languages. For example, consider a movie made in Asia where all the characters speak Vietnamese. To market the movie to an international audience, the spoken text needs to be translated into English. A translator would sit down and carefully translate all the text and create subtitles for the movie. Anytime someone wants to watch the movie, they can turn on the subtitles. This type of translation is the equivalent of compiling. Everything is translated once and can be used many times afterwards. Now consider a delegate from Vietnam giving a speech in the United Nations in Vietnamese. In order for the attendees to understand the speech, there are a number of translators who provide a translation that is transmitted to the attendees' headphones. This translation occurs close to real time. Every time the delegate speaks in Vietnamese, the translators get to work. This type of translation is the equivalent of interpreting. Text is translated line by line as necessary, and the results are not used again. Compiled code tends to be faster since the translation is completed in one step prior to the actual execution. Interpreted code, on the other hand, is more flexible and can be run interactively. For example, using interpreted code, you can try out a few lines of code to see if they work very quickly without having to go through the steps of compiling and executing the program. One advantage of using compiled code is that it does not reveal the original source code. This makes it possible to distribute a program without revealing its inner workings. When you install a software application on your computer, you are typically installing a compiled version of the code. You can run the software application, but you can't open up the source code in the original programming language. For many companies selling software applications, the original source code is a well-kept secret and gives them their competitive advantage over other companies. Examples of compiled languages include C and its derivatives, C++ and C#, COBOL, and Fortran. Examples of interpreted languages are Java, Perl, Python, and Ruby.
So I hope you understand the difference between the compiler and interpreter, right? So let's review again. Okay, so you have compiler and you have interpreter here. So for the compiler, actually you have the coding here. The coding, you can code it. It calls the source code here. Source code. So basically for the compiler, you need to run it one time only. You need to compile it and translate it to the executable here. Executable file. So when you compile it one time only for the executable time, to the executable file. So every time you run it, you just to run the executable file here. You don't have to compile. You don't have to translate it again. So for this one here, you have some benefit. The first thing, it works fast. You just need it to compile it one time. But every other time, if you want to run it, just run it. You don't have to compile it again. You don't have to compile it again, so work it fast. And the other one is that you can hide the source code here. So when you compile it and translate it to the executable file here, the user have no way to look into the source code. Think about the window. You have the source code here, and it's a proprietary. You have no way to look into the source code here. Okay, they work it fast, and you can run it for multiple times. Only compile for one time only. So for interpreter here, every time you have to working line by line, and you have interaction with the user. So what is a X, what is a Y? So every time you have stop and you have to interaction, you have to have the interaction with the end user here. So for this one slow, but of course it has flexible here. Right? So we can every time if something is not what you expected, you can go back and fix it very easy. And it's open code here. You can fix it here. Right? So it's up to it's up to the program and it's up to the output. You can choose working with a compiler or interpreter. It's up to you. Right? So for the compiler, you can have the C# or C++ here. For interpreter, you can have JavaScript, Python. Right? That's something like that. Okay, so now we move to the something about the I already mentioned about the syntax error. Remember, if you have the syntax error, the program will be stopped and have no way to run it, and it tell you what is error, and you have to go back to fix it. But the logical error, remember, for a logic error is an error in the program logic produced in the incorrect output. So basically for the logical error, when you run it, it runs smoothly. But the output is not what you expected here. Now think about, go back about the example of the calculate the area of the rectangle here. You have the length, and they have a width. Okay, so for the area, if you are the coder, you set area equal to the length plus width here. So when you run the program, it runs smoothly. Right? Nothing happen with the program here. So if you enter the number 10 and number 5 here, the output here is a 15. Right? The output is 15, it runs smoothly. But the output here is not what you expected. You expect 50 here. Right? So that is a logical error. So remember, logical error, when you run program, it runs smoothly. Nothing wrong with that. But the output is not what you expected here. Right? So that's why the testing is very important here. You have to a lot of the testing scenario and have to make sure the output is what you expected. Okay. Now you move to the variable. That is also very important here. Variable is the name of memory location whose value can vary. You have this one. Vary. That means changeable. Right? So you can think about if you want to write a program to double the number here. Right? So think about you have to declare x as integer here. Right? So after this one, when you declare x as integer, actually you declare a variable. So when you declare a variable, what happens? So in the computer, in the memory computer, it reserves one slot here. It reserves one slot in the memory computer, and this slot has name of x. That's enough. Have this name is like now. So you can have the you got the input from user, right? So it input x. So after this one, if user enter number 10, it store number 10 here in the memory x. If the user enter number 20, it store number 20 here in the memory x. Remember, this one is vary, this one vary. So the new one will override the old one here. That is something you have to remember about the memory, about the variable here. Right? So think about this one. Remember, let me give you the example. If I have the memory here. So now the process I set x equal to 10. This process is assignment. That means I give the value 10 to the variable x here. So now I set x equal to 20. Okay, x equal to. Now I want to print. I want to print out x plus x. So what do you think? What I have for this one?
40.
Yeah, right. Right, because here, the first thing you set 10 here. Alright, so now I get 10. Right? I get 10 now. But you see, the second time you assign 20 for that one, it overrides here. It overrides this one. So now it changed to 20. So what if you want to print now, I what is I? It reference to the memory. Here, right? It reference to memory. Now you know this one is 20. This one, what is X? It reference to the memory. You have 20 here. So when add them together, you have 40. Okay. So remember, when we're talking about variable, you have to think about vary here, changeable here, and the new one always overrides the old one. That is something you have to remember. So whenever you have variable, you have to think that you have one slot in the memory. It's the name here. Okay. Okay, so now we talk about the okay, program development cycle. What is it? Okay, program development cycle. So basically, for very simple program, you don't need to have all the process of the understanding the program, plan the logic, code the program here. But if you have a complicated program, you need to do it with the program development cycle here. So in the programming development cycle, you have step of understanding the problem, plan the logic, code the program, use the software. It can be compiler or interpreter here to translate it into the machine language. You have the test program. You have to put a program into the production and maintain program. Okay, to make it simple. To make it simple, let me give you the example here. Okay, so now, say my wife, she give me the comment, make me some cookie. That is the problem, right? That's the problem. She wants some cookie here. Why is changed to this one? Okay, now problem is a cookie. She ordered me to make her some cookie. It's enough or not? The problem here, clear or not? Problem here, clear or not? Why? Why not clear?
What kind of cookies?
Yeah, right.
How many cookies?
You have to very specific about the requirement here. In order to make the output, in order to make the expected output, right? You have to very specific about the requirement here, about the problem here, right? So we see what type of cookie, how many, right? You need it big or small, right? You need the chocolate chip or not, something like that. You always have a very specific about the requirement here. Otherwise, the output is junk here, right? It's a junk. So that's why the first thing you have to understand. You have to understand the problem. Understand problem. And you have to very specific. You have to raise the question to the user here. Right? So if you have if someone raise the problem, you always have to raise the question. You have very specific on the requirement here. Okay, that is the first step. You have to understand the problem. Right? So now I understand that she wants to make a pie cookie, it's a crunchy or something like that, and chocolate chip, something like that, right? Okay, now very specific. Now you move to the second one, you do the planning. So you know that she wants a pie crunchy cookie with chocolate chip. You have overview how to make it. Right? You have the planning how to make it. So you have to go to the grocery. You have to buy the flour, right? Flour, milk, sugar, egg, chocolate chip, something like that, right? And of course, again, this also very specific here. How many? How many? And in order to that, of course, you need the recipe here. You need the recipe here. So this one also very important. Very specific and very important here. And in the software development cycle, This is the two most important steps in the cycle. The first one is analysis or understand problem. The second one is planning. They are very, very important. So you see how many of them, very good here. You need to figure you have to figure out the recipe here, right? How to do it. Now you have to do it a step here. You need to put the flour and crack the egg and mix with the milk. You have to do it step by step, very, very specific here. That's why it's very, very important here. Now the third one, the first one, understand problem and analyze it here. The second one, planning. The third one, it is coding. Actually, the coding is very simple. The coding is just follow the recipe here. Just follow the formula here. Hey, how many flour? Put it. How many egg? Crack it. How many milk? Just mix it. And how long I put in the oven? That's one. You just follow the recipe. So actually, the coding here, it is a process. You follow the recipe and translate it to the expected output here. So in the coding, once you understand the logic of the analysis, when you understand the logic of planning, it's very easy for you to do the coding. The coding is very simple. You just convert it to the C++ or C# or something like that. Very simple. Now, when you're done the coding, actually you are done with the cookie here. You have to go with the testing. Now, give it to my wife. She eat it. It's good or not? It's crunchy or not? And it's too salty or too sweety or something like that. So after the testing here, you have to make sure you already got the expected output or not. If not, you only have to go back to freeze it. You only have to go back to freeze it. That's why you have the cycle here. Cycle here, that means anytime you can go back to freeze it to make the better output here. That is the thing. Now go back to this one. Okay. Okay, so we see you have understand the problem. It's very, very specific here. Specific. Or you can sometimes they call it analyze it. The second one, you plan. You plan the logic or make the plan. It's the coding. The coding that is convert the recipe to the action here. And you use the coding here, you test program here. So when test program is okay, you put it into the production here. And after that, also you have to maintain program. So if you have any feedback from the user, says that it's too slow, or I expect something is more specific, you have to go back it here. So it is a cycle. Every time you are able to go back at any step, not only after the testing. So in the process of the planning here, so I'm working with the recipe, and I think that somehow you miss some of the what is it? You miss a chocolate chip. So we have to go back here. Every time it is a cycle. So every time you can go back to previous step to complete the process here, to make a better expected output here. Okay. So that is a step of programming, program development cycle. You have to understand the problem, make the analysis here. You have the plan, you have the coding, testing, and put into the production and maintain program. Any question? Let me know. Okay, so we see that is a cycle. That is cycle. Every time you can go back anytime. You can go back anytime to make a better program here, to make a better output here. Okay. One of the most difficult aspect of programming you have to clarify about this is understanding the problem here or analyze it here. Problem analysis. So I mentioned that you always have very, very clearly about this one. You only have to very go into detail. You have only go into specific. That's why in order to make the output here, you only have to go to specific. So we have to collect information from the user. And it's very, very clear for everything here. And you have the documentation, it's all supporting paperwork for program. Okay, planning. Planning is a plan, the step, a program that what they include. And in the program, you can use the algorithm. It's a sequence of steps or the rule you follow to solve problem. That's the algorithm. So I think you should watch the video here. What is the algorithm?
Good grammar and spelling are important, but if you want to write essays that inspire,
What's an algorithm? In computer science, an algorithm is a set of instructions for solving some problem, step by step. Typically, algorithms are executed by computers, but we humans have algorithms as well. For instance, how would you go about counting the number of people in a room? Well, if you're like me, you'd probably point at each person, one at a time, and count up from 0. 1, 2, 3, 4, and so forth. Well, that's an algorithm. In fact, let's try to express it a bit more formally in pseudocode, English-like syntax that resembles a programming language. Let n equal 0. For each person in room, set n equal to n plus 1. How to interpret this pseudocode? Well, line 1 declares, so to speak, a variable called n and initializes its value to 0. This just means that at the beginning of our algorithm, the thing with which we're counting has a value of 0. After all, before we start counting, we haven't counted anything yet. Calling this variable n is just a convention. I could have called it most anything. Now, line 2 demarks the start of a loop, a sequence of steps that will repeat some number of times. So in our example, the step we're taking is counting people in the room. Beneath line 2 is line 3, which describes exactly how we'll go about counting. The indentation implies that it's line 3 that will repeat. So what the pseudocode is saying is that after starting at 0, for each person in the room, we'll increase n by 1. Now, is this algorithm correct? Well, let's bang on it a bit. Does it work if there are 2 people in the room? Let's see. In line 1, we initialize n to 0. For each of these 2 people, we then increment n by 1. So on the first trip through the loop, we update n from 0 to 1. On the second trip through that same loop, we update n from 1 to 2. And so, by this algorithm's end, n is 2, which indeed matches the number of people in the room. So far, so good. How about a corner case, though? Suppose that there are 0 people in the room, besides me, who's doing the counting. In line 1, we again initialize n to 0. This time, though, line 3 doesn't execute at all, since there isn't a person in the room, and so n remains 0, which indeed matches the number of people in the room. Pretty simple, right? But counting people one at a time is pretty inefficient too, no? Surely we can do better. Why not count 2 people at a time? Instead of counting 1, 2, 3, 4, 5, 6, 7, 8, and so forth, why not count 2, 4, 6, 8, and so on? It even sounds faster, and it surely is. Let's express this optimization in pseudocode. Let n equal 0. For each pair of people in room, set n equal to n plus 2. Pretty simple change, right? Rather than count people one at a time, we instead count them 2 at a time. This algorithm's just twice as fast as the last. But is it correct? Let's see. Does it work if there are 2 people in the room? In line 1, we initialize n to 0. For that one pair of people, we then increment n by 2. And so by this algorithm's end, n is 2, which indeed matches the number of people in the room. Suppose next that there are 0 people in the room. In line 1, we initialize n to 0. As before, line 3 doesn't execute at all, since there aren't any pairs of people in the room. And so n remains 0, which indeed matches the number of people in the room. But what if there are 3 people in the room? How does this algorithm fare? Let's see. In line 1, we initialize n to 0. For a pair of those people, we then increment n by 2, but then what? There isn't another full pair of people in the room, so line 2 no longer applies. And so by this algorithm's end, n is still 2, which isn't correct. Indeed, this algorithm's said to be buggy because it has a mistake. Let's redress with some new pseudocode. Let n equal 0. For each pair of people in room, set n equal to n plus 2. If one person remains unpaired, set n equal to n plus 1. To solve this particular problem, we've introduced in line 4 a condition, otherwise known as a branch, that only executes if there's one person we could not pair with another. And so now, whether there's 1 or 3 or any odd number of people in the room, This algorithm will now count them. Can we do even better? Well, we could count in 3s or 4s or even 5s and 10s, but beyond that it's going to get a little bit difficult to point. At the end of the day, whether executed by computers or humans, algorithms are just a set of instructions with which to solve problems. These were just 3. What problem would you solve with an algorithm?
Okay, so that is algorithm. Actually, it's a sequence of steps, a sequence of instruction you follow to some program. And in the planning, in the process of planning, basically you have the 2 most common planning tool. It is the flow chart, and the second one is pseudocode here. So let's talk about what is a pseudocode and what is a flow chart here. Okay, so let me mention about the flow chart and the pseudocode later. Now you have the problem, understand the problem or problem analysis. You have planning. Now you're working with the coding. Coding actually it is a process of convert the planning into the action here. So you have hundreds of programming language available. You can choose by on the feature or similar in the basic capability. Coding is easier than planning step. The 2 most important steps is the understanding problem or the problem analysis, and the second one planning here. The coding very simple. Coding is way easier than the planning step here. And for experienced programmers, they can successfully combine the logic planning and program coding into one step. If they are the experienced here. And okay, so using the software to translate program into the machine language, you can use a compiler or interpreter here, and you have to pay attention on the syntax error. The syntax error is the misuse of language, grammar, rule, programmer correct the list in syntax error, and somehow you need to recompile the code several times. Okay, and this is a translate, right? This is a translate here. So when you translate it, you compile program. If you have any syntax error, you have to go back to fix it. If you have no syntax error, you convert it to the executable program. So every time you run it, you just run the executable time, and you got the data, you got the input from user, and then giving out the output here. You need to compile it only one time. That is compiler. Okay, now you have testing program. So we have to test. That is a logical error. Remember, logical error, it runs smoothly, but the output is not what you expected here. Right? So that's why you have to make sure you always have to figure out on the testing scenario here to make sure the output is the one you expected here. And you have some definition about debugging. Debugging is the process of finding and correcting the program error, and program should be tested with many set of data here. That one is very simple. Sorry, very important here. You always have to figure out the testing scenario. In some of the case, you have a lot of testing steps here. Okay, putting the program into the production, it is a process depends on program purpose, may take several time. They have conversion, the intercept of the action and operation must take into straight over program. What is it? Maintaining program. It's making change after program is put into production. You have make change to the existing program. You can see the same with the window. You have a lot of upgrade. You have a lot of patches. That is something you need to maintain it. Now, you go back to the planning. So you have two major tools in the planning process. The first one is pseudocode. The second one is flowchart. Pseudocode, it is an English-like representation of logical step. It takes to solve problem. So the pseudocode is not programming. It is kind of simulation only. But it's very helpful in planning step. So when you understand the pseudocode here, it's very easy for you to convert it into real programming language. So when you understand the logic of pseudocode, you can convert it to the C# or C++, whatever it is. That is the logic here. The flowchart is the picture of what is it? Pictorial representation of logical step. So you can see on the chart, and you can understand the logic and you convert it to the programming language here. Okay, so we see in go to the detail here. It's a zero code. It's an example, very simple zero code here. All right, so you go with the start. That is start program. Right? The process here, input my number. My number here is a variable. So my number here variable. So actually you have one slot here in the memory. The slot name here is my number. Slot here is my number. So after this step here, you tell the user that you have to get the input here. So if the user enters the number 10 here, it stores the number 10 into the slot my number here. So now it's a calculation. You set here. So remember we have some keyword. Start is a keyword. Stop is a keyword. Input here is a keyword. Set here is a keyword, and output here is a keyword. Input, that means you got the input from user. Set is everything about calculation or assignment. So we set that. You have assignment here. You have to use the set here. So after that, you assign the number 10 to variable ID. All right. So here you have start, input, got input from user. Set, everything about calculation, operation, assignment. Output, giving out the output here. All right. So what happened here? Now you got input. If the user enter number 10, you do calculation here. My answer. So what is my answer? My answer, another variable. So you have another slot here. You have another slot. It is my answer here. Okay. So after this one, you set the my answer equal to my number. What's my number? It reference to this one. And now take out the number 10 and time 2. So we have 20 here. So after this step, you have the my answer is 20 here. But you are not finished yet. It only stored in the memory. The last step, you have to print out, right? You have to tell the user now the number is 20. That's why you have the keyword output here. What's output? What is my answer? Reference to my answer, you have 20. So we print out the 20 here. Okay? That's the process of the pseudocode. It's very simple here. But one thing about pseudocode here, one thing about programming, you will have to pay attention here. So variable name, you must be consistent with variable name. All right, so think about this one. You have my number. You have my number. That means you have this one here. You have slot name is my number. All right, but somehow after the set my number, you put the at here. You got syntax error. Why? Because here it look it up. What is my number? It look it up on the memory. You have no variable name my number as it. So for this way, you got the syntax error. So you have to remember about variable. You always have to be consistent with variable name here. Otherwise, you got the syntax error. A lot of students got the simple mistake here because the name is not consistent. Okay. And the second one here also, it is a syntax error. But somehow you put the number time, but the number 3 here, you got a logic error. It's not double. It's not double here, but I triple here. That is a logic error. Okay. So that is very simple example of the pseudocode. Okay. Pseudocode standard. The program begin with the word start and end with the word stop here. And these two words are always aligned. They always align together. If you can see, they align together here. And whenever the module name is used, it's followed by the set of parentheses. And module begin with the module name. We look into that later. We look into that later here. Okay. Each program statement appear on the single line, possible and not possible continuation line indented. Okay, program statement begin with the lower case letter. No punctuation is used statement. Now, Remember, in the planning, you have two major tools. The first one is pseudocode. The second one is a drawing with a flow chart here. So when you flow chart, you have to create the flow chart. So let's see what we have the video for this one. Oh. Sorry, this one. Oh, seems that I have to. What is it? Okay. Okay, so you see that is that is very simple. Sorry, that's very simple flowchart. So for the flowchart, you have the start and end here, and for every input, it is a parallel logo, right? That is so for the input, it's a parallel logo, and for the output also, it's parallel logo. But everything is a processing here. Every processing, it is a rectangle. And for everything about the decision that means it's correct or not, yes or no, true or false, it is in the diagram here. So that is a symbol of the very simple of the flowchart, and you have to, when you look onto the flowchart, you see they have the two input here. You have to enter the mileage here. You have to enter the current mileage here, and you have to do with the processing here. You see how many miles you already go from the last chain here. Right? So from that, you make a decision, yes or no. Yes, greater than 5,000. Change no here, right? Do not change the oil. Greater than, change the oil here. Okay, that is the way you can read the flowchart here. Okay, so here you have the output symbol. You have the output symbol here. It's also parallel logo. I remember the input here. Input here is parallel logo graph. You have processing, it's a rectangle. It's the output, parallel logo graph. You have flow line that connects them together. You have to connect them together. And you have the terminal symbol. You have start and stop here. And so see, you have start and stop, you have input, you have output, and you have processing. And in the serial code, is that what it look like? It's a serial code here. Okay. Now, about the repeating instruction. See if I have the rafter here or not. No, I don't have rafter here. So let me see. I can download the rafter here. Yeah. So Raptor is a free software. It uses to simulate the program, and in this class you also have to work with Raptor. Okay, so now looking at the repeating instruction. So we see this is a process. This is a process. If you want to double the number here, you have to input the number. You do the processing by double the number, and it print out the output number here, right? But sometimes you need more than one time. Right? Sometimes you need more than one time. You need the print out for you need to do it for 1,000 times. Right? So in the case that is a here, I don't have it. So why? Okay. So here is example, the very simple example, right? So in some program, for this one, it's not feasible to run program over and over one for 10,000 times, right? Sometimes if you want to do the 10,000 times, you can think about here. You copy for the 10,000 times. You have no way to do that, right? So in that case, you have to work in the loop. In that case, you have to work in the loop here. You have to create the loop, and you have to do the repetition here. And you tell how many times you want to do with the loop. You have to tell how many times you want to do the loop here. Okay. In the case of the loop, you have to make a decision. Okay, so now you move, I have to go back a little bit about this one for next Tuesday when I working with the Raptor here. Right now I'm not using this Raptor on the computer. Now we move to understanding the programming and the user environment. So basically, in order to write the program, you have multiple ways to do that. You can work with the text editor here, so we can go with the Notepad. You can go with the Notepad, and if you understand the syntax, if you understand the logic, instead working with the Notepad here, so we have a print. So we can work in your print here. So hello, something like that. And if you want to do with the Python, you can save. You can save with the Python here. py, something like that. That's the py. Of course, I don't have the Python here. I have to do with it. I have to do with it on the display. Okay, so in order to write the code, you're able to work it with the text editor. It can be the Notepad or whatever it is. Or you can go to the integrated development environment, IDE here. And it's a provide editor, compiler, and other programming tool. I'm really sorry I don't have the Python here. The thing is that the school here, they don't change everything to the learn anywhere. So they upgrade a lot of computer, and some of the computers not ready with the software for that. But I can show you that on the Tuesday I'm set and have everything set again. Okay. So I think some of them I have to review about on the Tuesday. Now come back to the class. Let's see what you have for this one. So you have discussion here. Discussion here. What is it? Okay, so introduce about yourself. You can record it or you can share any picture you want and discuss about the algorithm. You have to read about the work ethic. So when working on that, you are supposed that you have to read something here. You have to read about work ethic here. Our effective communication. What is algorithm? Pseudocode, flowchart, system development methodology. Okay, this one. So you have the two discussion here. Well, this one is a software development methodology. You have some of the thing you are supposed to do. You read it and search it on the internet and the basic discussion with this one. Now we go with this one here. Debug the exercise. So debug exercise. To complete this one, click the link. Debug exercise in the next session. So you have to go to download here. And this one, you have to go download. You have to go to the My tab. Okay, what is it? Okay. So for each of them, each of the one determine the program and fix the error. And after you correct the error, save the file using the same file name. Proceed with the fix here. Right. So for this one, you have to put the fix for this one here. Right. And you save it. It's exercise your homework. You follow instructor direction. So now here, for this one, you have the four. You have a four problem. You need to debug it. So here's the thing. If you look on this one, what is the problem? Thing I had to. You have to zoom it here. Can I zoom it? Why not able to change? Okay, it might be simple. Right? So here's the thing you need to debug it. So if you look on this one, what is the problem? It is zero code here. It is zero code here. What is the problem with this one? Yes.
It's calculating 25% and not 10%.
Yes, very good observation here. Okay, so we see you need the 10% here, but right now you set it 25%. Right? Anything else?
Discount is spelled wrong the second time.
This one, right?
Mhm.
Yeah, because the variable name is inconsistent here. They're not the same. Right? This one here. So actually, how it works on this one? You have one variable here. The name of the variable is all price here. Right? Right? You have another variable. You have the discount here. And you have the price here. So what happened? You got the input from the user, original price here, right? So think about this one. You have 100 here. All right. After that, you have to figure out what is the discount. What is discount here? Anything wrong with this one? Anything wrong?
It's price and not
Yeah, also.
original.
The price here, you have no way. What is the price here? Right? Actually, you have to working with the original price here. Right? So actually, you have a lot of things with this one. You have to replace this one with original price. Otherwise, price here, you have no idea what is it. You not got the input from user, right? You have no idea, is it? So this one is also we have to change it to the original price here. You change it to the 1.1 here, right? And final price, original price minus discount here is not correct also, huh? And this one correct here, right? Because they are inconsistent here. Huh? So that is the way. And remember, after you done everything in this one. So let me do this one. So you have to change this one to O R I G here, right? And of course this one has a price here. The name must be consistent, right? So you see this one and this one must be consistent. And this one also you have discount. Right? And change this one to 10. And remember that you have to save it. You have to save it with the first before that and submit it. Okay. Now, okay, good. Okay, so now do the second one. What about this one? This is a pseudocode. It's intended to compute the number of miles per gallon you get with your automobile.
Used in gallons of gas on the second.
Sorry, say again.
You forgot the used on gallons of gas.
Yeah, right. This one. This one is must be this one here.
And then it's mils per gallon instead of miles per gallon.
What?
It says mils per gallon instead of miles per gallon.
The output,
Oh, this one, right? Yeah, this one here. It must be this one. Anything else? Anything else? This one have a logic error. Why? You have to
you
divide.
divide.
Yeah, you have to divide here, right? That not plug here. That is a logic error. Okay, so for this one, you also have the something to write. Okay, how about this one? This pseudocode is intended to describe computing per day to cost of your rent. Let me open this one. Okay, what do you think for this one?
Should be 30 if it's 30-day month. 31.
Yes, that is the first one. Anything else?
The output should
Yeah.
be cost per day.
Output is a cost per day, not the rent. Rent here is a monthly. So what you expected here, it is a per day here. So we have replace this one. We have cost per day here. And one thing about this one, I'm not really sure they make mistake or somehow they accept it. But normally for the pseudocode, for every calculation, every assignment, you have to put the set here. You have to put the set here. And so should be better for you. You correct everything with the calculation or assignment. You have to put the set. But I don't know why. I checked for all the other ones. They don't have the set. They don't have the set keyword here. They don't have the set here. But it should be better you put the set here. And you put the set here and here. Now, what is the last one? Oh, this one is a flow chart. This one flow chart. Start, input the table spool. Program convert table spool to T spool. What is it? Oh, table spool and T spool. Okay, so one tablespoon is a 3 teaspoon, right? Okay, makes sense. So what is wrong with this one? What's wrong with this one? What's wrong with this one?
Every teaspoon equals tablespoons divided by 30 tablespoons.
This one, right?
Yeah.
So what you expect is a teaspoon here, right? So we have to replace this one with teaspoon. It's not tablespoon here. So we have to put it teaspoon for this one. Okay. So you suppose that you have to download the router. Oh, this one is instruction here already. Again, I'm not able to install the router. It's a portable here. So why I'm not able to install it? Question. This one here. I think this one works. Yeah, this one works. Yeah. Okay. Good. Let's see. I need to have I don't have a check account. Sorry for that. I have to fix it. Okay. So for this one, you have to working with the router. I will install the router next. Okay, now try to work with the Python. Okay, so here is the structure of the Python. It's very simple. Very simple. Okay, so this is a command. That is the keyword. Print and everything inside the parentheses and inside the double format. You print out the tag here. Alright, so you can for this one. How will work it? Enter. What is it? This one. Yes. So you see, and that is print out the tag here. So it's up to you. You can modify whatever you want. So hello world. It print out the hello world here. Yeah, print out the hello world. Okay. Now come back to this one. Execute program. There should be no syntax, no the output of this program. It here, right? Modify program. So display I am learning how to program in Python. Super simple. Alright, you just copy this one, replace it here. Delete one. Oh, sorry. Okay. Connect. And modify program. So it print out the 2 line at the second line. That's awesome. So I just copy this one, put into the another one, and it here. Very awesome. Okay, run it. Yeah, so we have to Now click submit. Where submit? Where? How to submit it? Where the submit? Where? I don't know. Where the submit? No. I think this sorry, this one. No? Where the submit button is? Question. You can try it. Now see what else. Computer program, also know what is it? Huh?
Software.
Yeah, software. Second one, major program operation includes. Sorry, major computer operation include. Yeah, input, processing. What is it?
Programming languages.
Yeah, programming language. What is a programming language rule? What is it?
Syntax.
Yeah, syntax. The syntax. Rule is the syntax here. The most important type of compiler or interpreter is what is it?
The C.
Yeah, right. C, correct. So it's like as a high-level programming language, and ultimately, for every program, you have to translate it into the machine language here. Thank you. What is a Swiss?
G.
Yeah, B. Actually, it might be the rhyme. Which is following it? I think I should. Okay, which is the following pair step in programming first is in the correct order. Which one? Which one is the correct order?
A.
Yeah, you have to code and translate it. It's a program for important time before planning. You was not remember about the development cycle here.
Is a B.
Yeah, right? That's the first step here. It's understand the problem or problem analysis here. You have two more important tools. What are they?
B.
Yeah, you have flowchart and zero code. And what is the process of writing program? Writing program. What is the process of writing?
Coding.
Coding. The coding is the process of that. Yeah. An English line programming language such as Java or Visual Basic is a so what? High level. High level here. Which the following is an example of syntax error?
B or D?
C.
Misspelling. I think C is more correct. Actually, I producing the output before assembly. I don't know. Absolutely not. This is the logic error, not syntax error, not syntax error. But about A and C, I don't know. Maybe C. Yeah. Which the following is example of logical error. This one, right? Parallel program is a flowchart single operation. What is it? What is it? You look at this one here. In the flowchart, parallelogram, it is for the input and output. Input and output. Processing, you have rectangle. Decision, you have a diamond. So this one is A or B. Oh, what is it? Rectangle, what is it?
Processing.
Processing. Processing. Flowchart, decision. Decision, everything up. Correct or not? Yes or no? True or false? That is diamond here. Yeah. Oh, why I don't have this one? Oh, maybe yes, this one because I am not able to install the router yet, so that's why I skip it for next Tuesday. Talk about that later. Oh, talk about that later. Later. Okay, this one I think. You should watch this video. Very interesting here. Yeah.
If you're learning to code, I can almost guarantee that you're taking the long road instead of the shortest path, and frankly, that should terrify you. Most people.
This one they tell the difference between procedural coding and object-oriented coding programming.
A popular interview question concerns the 4 core concepts in object-oriented programming. These concepts are encapsulation, abstraction, inheritance, and polymorphism. Let's look at each of these concepts. Before object-oriented programming, we had procedural programming that divided a program into a set of functions. So we have data stored in a bunch of variables and functions that operate on the data. This style of programming is very simple and straightforward. Often it's what you will learn as part of your first programming subject at a university. But as your programs grow, you will end up with a bunch of functions that are all over the place. You might find yourself copying and pasting lines of code over and over. You make a change to one function and then several other functions break. That's what we call spaghetti code. There is so much interdependency between several other functions.
Now here's the thing when we think it's a procedural. You have the function, for each function when you execute it, you got the input here. Right? You have the word input and they are interdependent together. So when they interdependent together, whenever you change anyone, it impacts everything. They call it spaghetti coding.
Break. That's what we call spaghetti code. There is so much interdependency between all these functions, it becomes problematic. Object-oriented programming came to solve this problem. In object-oriented programming, we combine a group of related variables and functions into a unit. We call that unit an object. We refer to these variables as properties and the functions as methods. Here's an example. Think of a car. A car is an object with properties such as make, model, and color, and methods like start, stop, and move. Now you might say, but Mosh, we don't have cars in our programs. Give me a real programming example. Okay, think of the local storage object in your browsers. Every browser has a local storage object that allows you to store data locally. This local storage object has a property like length, which returns the number of objects in the storage, and methods like setItem and removeItem. So in object-oriented programming, we group related variables and functions that operate on them into objects. And this is what we call encapsulation. Let me show you an example of this in action. So here we have three variables: base salary, overtime, and rate. Below these, we have a function to calculate the wage for an employee. We refer to this kind of implementation as procedural. So we have variables on one side and functions on the other side.
That is procedure coded here. So we see you have a function, and whenever you execute function, you got the input, and the input here is not encapsulated into the function here. Right? So you have dependent on this variable here from the function, right? From the function point of view, you have a dependence on this variable here.
Are decoupled. Now let's take a look at the object-oriented way to solve this problem. We can have an employee object with three properties: base salary, overtime, and rate, and a method called getWage. Now why is this better? Well, first of all, look at the getWage function. This function has no parameters. In contrast, in a procedural example, our getWage function has three parameters. The reason in this implementation we don't have any parameters is because all these parameters are actually modeled as properties of this object. All these properties and the getWage function, they're highly related, so they're part of one unit. So one of the symptoms of procedural code is functions with so many parameters. When you write code in an object-oriented way, your functions end up having fewer and fewer parameters. As Uncle Bob says, the best functions are those with no parameters. The fewer the number of parameters, the easier it is to use and maintain that function. So that's encapsulation. Now let's look at abstraction. Think of a DVD player as an object. This DVD player has a complex logic board on the inside and a few buttons on the outside that you interact with. You simply press the play button and you don't care what happens on the inside. All that complexity is hidden from you. This is abstraction in practice. We can use the same technique in our objects. So we can hide some of the properties and methods from the outside, and this gives us a couple of benefits. First is that we'll make the interface of those objects simpler. Using and understanding an object with a few properties and methods is easier than an object with several properties and methods. The second benefit is that it helps us reduce the impact of change. Let's imagine that tomorrow we change these inner or private methods. None of these changes will leak to the outside because we don't have any code that touches these methods outside of their containing object. We may delete a method or change its parameters, but none of these changes will impact the rest of the application's code. So, with abstraction, we reduce the impact of change. Now, the third core concept in object-oriented programming: inheritance. Inheritance is a mechanism that allows you to eliminate redundant code. Here's an example. Think of HTML elements like text boxes, drop-down lists, checkboxes, and so on. All these elements have a few things in common. They should have properties like hidden and inner HTML and methods like click and focus. Instead of redefining all these properties and methods for every type of HTML element, we can define them once in a generic object, call it HTML element, and have other objects inherit these properties and methods. So inheritance helps us eliminate redundant code. And finally, polymorphism. Poly means many, morph means form. So polymorphism means many forms. In object-oriented programming, polymorphism is a technique that allows you to get rid of long if and else or switch and case statements. So back to our HTML elements example, all these objects should have the ability to be rendered on a page. But the way each element is rendered is different from the others. If we want to render multiple HTML elements in a procedural way, our code would probably look like this. But with object orientation, we can implement a render method in each of these objects, and the render method will behave differently depending on the type of the object we are referencing. So we can get rid of this nasty switch and case and use one line of code like this. You will see that later in the course. So here are the benefits of object-oriented programming. Using encapsulation, we group related variables and functions together, and this way we can reduce complexity. Now we can reuse these objects in different parts of a program or in different programs. With abstraction, we hide the details and the complexity and show only the essentials. This technique reduces complexity and also isolates the impact of changes in the code. With inheritance, we can eliminate redundant code, and with polymorphism, we can refactor ugly switch case statements.